Welcome to Open Source and Environmental Sustainability. So we had no time to actually sync up on the slides, Eirini and me. So we are actually not doing this full time. We are just a community of people that actually investigated what is the impact of open source and environmental sustainability. So I'm actually an aerospace engineer working in atmospheric science. I do this really now 2.5 years, since 2.5 years. So we started actually a small awesomeness, it's called in open source, where we just collected a lot of projects that are dealing somehow with environmental sustainability. So it was really the purpose to just give an overview of this ecosystem, because there was nothing before to see, okay, what does it mean, open source and environmental sustainability? The whole project was actually being created within protontypes. That's just a small community we created to have some brand and to some namespace to work together. And Eirini joined 1 year ago. She had actually a grant from SOOCon23. That's an accelerator program here from the UK that gives money to people who want to open up data that is relevant to our environment. And John Hopkins from Open Corridor also joined, because he was very interested in a lot of tools that we were investigating to see how he can integrate it into a new open source framework. So he wants to really reintegrate those projects in a new framework. So let's start about what is actually environmental sustainability. It is actually it's the goal about preserving the resources of our planet for future generations. And you see on the right-hand side, that's actually a simulation of our planet with the atmospheric model called SCREAM. It is here simulating the water vapor and how it changes in the future, because within a heating planet there will be more water vapor in the atmosphere. And this as a water vapor itself actually acts as a climate gas. This is an accelerating problem, and this is what we are actually facing now. We are facing an itself accelerating atmospheric problem. And since we are also losing biosphere, we are not able to store that easily again, the carbon back into the ground. So what does it require actually to be sustainable? I wrote here, you need the intelligence and the intention to really understand. That's important, to first start with the understanding. Then to also predict the future. So it's a lot about predicting the future for 20, 30 years. How does our environment and our society in combination change? But it's also very importantly about how to manage our resources that we have on this planet. So the core question about the study was what enables open source environmental sustainability. And this is so important because open source has such a massive impact on our world, because it's really part of 79% of the code bases that we see in our products today. And this can be measured by companies like Synopsys that are doing actually security auditing. They go there, they look into the code, and they measure this. So what we did in the study is we really looked at the state of this open source ecosystem. We created insights, but we also created the open sustainability principles within the report. And we created, based on that vision, strategies and potential that we see, because we had so many talks, and Eirini did a lot of interviews with people that gave us, I would say, a unique idea about what software in general can play for a role in environmental sustainability. So let's start with environmental intelligence. So one very important aspect is really to understand our planet and how it is changing. And here satellite data, but not only satellite data, but also local data can be important. But satellite data gives us a way to have a highly calibrated sensor that flies all over the world and gives us many information for different indicators about our environment, like air quality. How does our forest change? Is there a deforestation, or how does reforestation actually work now? Is there actually emissions? So we can really measure methane emissions by point sources and say, here you are emitting this amount of methane in this time slot. But it's also about what most people don't know about biodiversity. Like satellites have so many colors, they cannot see like red, green, blue, but they have sometimes thousands of colors, and the amount of colors that you see in the environment is a very good indicator about how does biodiversity change. If it's a monoculture, there you don't have that much you will not see many colors there. But it's also about how our urban vegetation changes, where are heat islands within our cities, where do we want to go when there's the next heat wave here in Europe. But also things like how does the soil change. So you can penetrate actually the soil of the earth and see what's the moisture, what's the quality of the soil, and how does it change, because it's a very important indicator how does really our environment change over a long time. And there's also the application of this technology. It's not just creating intelligence, but we also can, with open source and open hardware, open data in combination, create, for example, a 50 megawatt wind turbine that has been developed with multiple European and American companies together, that where the simulation, the blueprints, and everything to actually design those wind turbines is all being open sourced. But it's also about like improving the hardware that we have. Like with PV Lab, you can calculate what's actually the orientation of my PV panels, the photovoltaic panels, right? And where should I maybe put it in the future? And that's a very important aspect, because it's one of the most promising renewable energies that we have at the moment. But another interesting project is PIPESA. It's actually simulating the energy system of our whole planet, and it can predict how can we change this energy system to decarbonize it. And you see here actually a simulation of the energy system from India that has been done by this project. It's a very collaborative effort between multiple organizations that try to together create a framework to do energy system modeling on a global scale. So the methodology that we actually created to do the study is also new for open source in general. We did not just look on our dependency tree and look there where there's some risk from our perspective. We really wanted to see what is really the whole ecosystem on the topic, and that's why we started with curating actually a list. It was really just a markdown list. Everybody could throw projects on it. There was some guideline with kind of projects and how they actually needs to be listed, and we put them in different fields and topics, and we also from the beginning, we created this list in a way that it is possible, so that a machine can read this list, and so that we can actually automatically collect the metadata of those projects. And then we decided, okay, these are really great projects, and we took from every field projects and people we would like to interview, and in Eirini did the interviews with all those people to get not just quantitative data, but also qualitative data about what is actually the impact of such a project, because numbers sometimes can be a little bit misleading in this way. And after that, we created this collaborative report as 3 core authors together, and try to cross-validate actually what are the qualitative and quantitative insights that really fit to each other, to see, okay, there's really a pattern that we can see. If you would like, this whole plot is in the report fully interactively, so you can actually really discover all projects there. If you click on Earth and Climate Modeling, then all the projects will be visible in the sunburst diagram. Here, this is the overview of the data set that we created. So it's more, at the moment, more actually than 1,339 projects. We focused actually our project on GitHub because we had not the time to integrate other APIs and platforms, but we would like to do this in the future. I see this as a very important aspect. As you can see, you can see here how many projects are actually in a personal namespace, so which are just created by a person, and which are in a community namespace. But we also evaluated which kind of projects are still active. So from the beginning, we tried to just list projects that are active, but within the study itself, a lot of those projects got actually inactive, and that's the common problem with open source, that most of the projects will get inactive. But we also created like the median development distribution score that shows you actually how much is the knowledge spread in this community. I will give you some better numbers. This is actually the median number that shows you actually that 70% of the work in an open source project in this ecosystem is done by one person. What is not in general a bad thing. I must say. So the first thing that was very clear is that this domain is very unpopular, I must say. So if you list all the stars, so stars are sometimes misleading, but they give you an idea about how does the open source ecosystem actually look on those projects. And you can see, the whole open source ecosystem. So it is popular actually on GitHub itself. And you can see here that actually we found 3 projects that have more than 1,000 stars. And on general, you find nearly 40,000 projects on GitHub that have more than 1,000 stars. And for me, the biggest indicator is that our project itself we removed them from the study, but we are on position 3, so we are on one of the most popular projects in this domain, and this is not a good sign, I would say, because this is one of the largest problems we are talking about in this time, right? And also that we needed to do the studies also, I would say, sometimes for me strange. But what you find there in the popularity, actually, this kind of projects that are easy to participate by contributors. So where you don't need a lot of expert knowledge to get into. This, for example, AB Street is just a gamification of a city, so that they can actually, so that everybody can participate in this game as an agent, so that you can improve the city infrastructure to support the transition line, so where to go, and to make the public transportation more sustainable. So it's really gamification of public transportation as a kind of simulation. And then comes Electricity Map. It's I would say, most successful project in this domain. Because AB Street is just really one person. Electricity Map has about 300 contributors. You see it on the right-hand side. And this is really some project that try to create an API that gives you on every location on the world. I'm using now this amount of electricity. What is actually the equivalent in carbon for this amount of energy that I used at this point? Very important for a lot of other projects that you see here, but you will also find projects like Open Food Network that try to create a very common understanding about what actually is the information that we have about food, because there's a lot of, I would say, misinformation about food and how it impacts our body or the climate. So it is, let's say, a very but you see a lot of energy-related and also climate-related projects. It's a lot about really measuring our world. And if you look on the right-hand side, you see the contributors totally different. But there, suddenly also the SCREAM project I showed you, this atmospheric modulation framework appears, and many other projects that really dealing more with, let's say, the core aspects of our environment. You see also there are a lot of catalogs that just gives you a good API to access all the environmental data that are already existing there. The color bar is this development distribution score that we developed that just shows you, is this just one person or is this 100 persons that are working in this project, as a good just to give an indicator about what kind of project and community you are dealing with. It's not in general a health indicator, I would say. It really depends on the kind of project we are looking at, but it gives you sometimes good information. The license and languages of those projects, the most of those license projects used actually the MIT license. What makes them good for reusing in a commercial product, for example? You can use those projects without participating anything, actually, within a commercial project. What has had some good sides, but also bad sides, and that's why there's the GPL 3.0 that actually is preserving a little bit the community in a better way. We had the custom license, actually we could not get from the GitHub API the license itself. And if you have a GitHub project and you don't see this logo on the side, what is actually licensed, then we could also not get this information, and it's not always good. Because, let's say, people want to have standardized license. So it's always good to have a standardized license that can easily be read also in a machinable way. Yes, then if you look in the programming language, it's also very interesting because if you compare it with other ecosystems, okay, there's Python, still great. I think most people know that. That's one of the most used programming language worldwide. But normally it is a little bit in competition with JavaScript, but in this domain it's not that important. But R, that is normally used a lot of in statistics, and like environmental sustainability is a lot about statistics. And that's why it's here so prominent. Fortran and C++, these are the programming languages if you really want to make large-scale simulations about our Earth. And that's why you see them here. And Fortran shows us, normally if you would create a new project, you would do it in C++. But Fortran is the project that it's one of the oldest programming languages that we have. And it shows that some of these Earth simulations that we do are very old. And there's some legacy code that was ported and maintained for decades sometimes. The origin and form of our organizations that we found, so most of them are actually from Europe. And then directly comes the North American continent. A lot of those projects actually consider those, or a lot of those, organizations consider themselves as global. What was, for me personally, a little bit shocking is that actually from the Asian continent, where a lot of products are coming from, where a lot of energy and a lot of environmental impact is being created today, and also a lot of money is there we do not find communities. That was, for me, I really tried to investigate more and find more projects. I looked on the Chinese Git platforms to find good projects that could be listed and keep to our requirements. I could not find them. Yes, if you look on the forms of organizations, most of them are communities, so no legal structure behind them. But they really show that open source is still a grassroots movement. They are really coming from the bottom. It's not that most of those projects come from academia, what is on the second place. So like we are community projects, and there's a lot of other community projects in this area, and I would just want to show you that actually open source is a perfect way to do climate actions from at home, very comfortable. You don't go directly on the street, but actually with just showing the data in the right way can be very impactful. Academia, that's I think not, you can imagine that there's a lot of academia project, but also government agencies play their important role. And then comes the non-profits that are, from my perspective, very small, and in general I cannot say that there are a lot of, I don't have good examples besides Electricity Map that are really, let's say, very good, big for-profit projects that are in this domain of environmental sustainability. That already shows us a common pattern that I will go more in detail later on. So if you look on the projects and topics, so we created this scatter plot, and you see here the beginning actually of GitHub, and there was one project of photovoltaic that started really at the beginning directly. Yeah, we are a year on GitHub, but then it was a little bit silent. But in general, I must say, we found quite a lot of good projects, but especially in the area of biosphere, mobility, and you can also see it here on this conference, a lot about mobility and transportation. It's about energy modeling, but there's also a lot about hydrosphere. It's a lot about water, soil. So it's really about the state of our environment. It's a lot. Okay, energy is not really the state, and mobility, they are really dealing with improving actually our personal impact. But if you go then down, you see areas like battery, or sustainable investment, and carbon capture and removal, where I also would put carbon offset into. A very hot topic. There's a lot of money going in this, billions of dollars going into carbon offsets today, but nobody knows how and why this is actually being considered sustainable. Generally, I would say the trend is really energy and climate is really top. So we know about our state, but we don't know really how to get out of this problem with open source so far. Also hydrogen, what is very hyped at the moment. There does not many models exist that really proves you that hydrogen is the future. For me personally, if somebody tells me hydrogen is the future, okay, show me a model that shows this, improves this open source, and then I believe you. And if you don't show me that, it's some plot maybe that you created. Everybody can create a nice plot. So yeah, that's, let's say, the quantitative analysis that we did, the numbers. But I want to talk to you also about the recommendations that we did. And I picked 2 recommendations, combined them with each other. I want to just show you what can be done with open source. So what are really the potential and the untapped things that we have not done so far. So sustainable investment is a huge thing at the moment. And all these pension funds and all those companies, everybody wants to have his money invested in a sustainable way, and this is the United Nations Principles for Sustainable Investment. They were created, you see it, 2006, and then like a lot of different assets actually signed this and said, okay, we want really to invest based on those principles. And we're speaking today about 120 trillion dollars that are actually invested per year based on sustainability ratings and those principles. That's really a huge number, and it will soon. There's a lot of people saying that most of the investments we are looking at will be rated and investigated based on sustainable investment. It was for me, I looked a little bit into this topic because I was thinking, it sounds great, and if we can get a lot of money, maybe we can also invest it in other topics, so it is really accelerating itself, so money rules the world, and it's not just always the politicians that makes the world, but it's a lot of times just the money, and it scales globally. And the ratings we look at today, this kind of sustainability ratings that also include, I must say, social sustainability and the government sustainability, they are created by a black box, I must say. Just corporations make sustainability reports. There are standards, but there's nothing like open science into this. So there's really, like in climate science and these other domains, open science is very strong. And you need to create certain things today in an open science way. But if it's about how do we rate a company if it is sustainable, there we have like really a black box. It's really this reports, and then this sustainability assessment agencies, they normally go there, get some news about corporations, and based on that they do a lot of natural language processing, and then suddenly comes there out a number. And this is really steering our world at the moment. That's a real problem. And this is also being said by a lot of scientists. So it's a little bit like throwing the dice. And you see here actually the sustainability rating that has been done by Sustainalytics. compared to the other rating agencies. And it's a little bit like throwing the dice and seeing, okay, what happens. So you just go to the next rating agency, and maybe there you will be sustainable, no problem. So just go to the right sustainability rating agency, and you will be sustainable. Even like ExxonMobil and other big oil companies are actually being rated sustainable in this way. No problem at all. And also the offer is here saying, addressing ESG, what is this kind of rating, environmental sustainable government rating, divergent requires one to understand how the data underpins ESG ratings are generated. So he says, I don't know how this data has been generated, so I cannot really tell you why this is where this high divergence is coming from. Yes, so carbon offsets and credits, the same problem. We have there on the one side people saying, yeah, I do actually, this was in The Guardian, I did this kind of, this amount of carbon offsets. And then there is The Guardian saying, no, we measured and it's actually that 90% of those carbon offsets are actually totally misleading. So carbon offsets are normally that what you so there's actually no carbon neutral product today. It's just that you pay somebody who tries to store this carbon in the ground, sometimes by planting trees. They plant some trees, go away, nobody measures. Here, I planted you a tree, €1. Okay, everything done, problem solved. Yes, and the problem with that is we're talking here, it's not a joke anymore, and most people do not understand this. It's really something that is really safety critical getting. And then also, if you talk to militaries, actually, they say it by themselves now, it's getting safety critical, what we are talking about here. So we exactly know on what path we are, and you can't trust those models because they're open science. If you have a problem with climate change, go there, make an issue on the climate model and improve them. Okay, that's the deal always what I say with those kind of people who don't trust this. It's all open, and the data is highly calibrated and recalibrated many times. But if it is about steering away from that, there we are missing the open science, the open source, and the openness in general. That's a trend that was visible inside our study. But there's help. Especially in the energy, there was this free the models movement. They said, yeah, let's stop this with these plots, and somebody show me a plot, and then comes other and show me a plot. If you cannot provide me the data, the open source code, the way how to execute your code, the open results of the output of your execution, if you don't allow open discussion about what we are looking at, and if you don't show me the uncertainties also at the end of your models and your data, then I don't just trust your plots. And it's a very easy way to stop those conversations about lying about plots. Just if there's no openness in general, there's no traceability, and you cannot really say about your uncertainty in environmental sustainability. And I was working in automotive, that's totally normal there. So you need such a chain of trust and show traceability when you make safety critical decision making. And we realized, okay, that's crazy. Openness itself is actually a key indicator for sustainability. So that means if you're open about why something is sustainable, then maybe you're wrong. But you show intention that you actually want to be sustainable in the future, because you can improve yourself over time. You can get in a discussion with somebody. You can say, my models were wrong, and here's a bug fix, and here, this needs to be recalibrated, here we need to integrate this and that. But it's so hard to predict the future. We need to really open up those models to get in a conversation about what is actually being considered in the future sustainable. Has also been referred a lot of time for standing off the shoulders of giants. The shoulders of the giant you're standing on, they should be rock solid. Okay, it should not be some plots here. But calculated something in here. No, that's not the way to go. And there are other great ways how to deal with this problem. And this is actually here in Oxford, there's an initiative called Spatial Finance, or the Spatial Finance Initiative. They use just Earth observation data to track down the fossil fuel industry. And also they have the database of the supply chain for the steel industry, the cement industry. And it's not just, let's say, the tier 1, but also tier 2. So you have the sub-supply chain of the supplier that you have. And they created those data sets and try to give now the financial institutions those data, because suddenly, and that's very important, you have a way to measure this objectively. Because before, the environmental sustainability ratings were not really objective, and scientists could not really participate into that. It was really a black box that was happening there. That's why what I would like to propose is a new way to actually rate the sustainability of a company, that we say, okay, let's integrate their Earth observation. Because we have, as I've seen, I showed you that on the second slide, there are so many environmental indicators that we can today create. And this data of most of those environmental satellites is open. So we can use this in these ratings. You cannot use it for all cases of environmental sustainability, but you can see, for example, if the coffee plantation where you get your coffee from, how does the biodiversity change in this area? You can see how the soil is changing. And if he is promising you that he really looks for biodiversity in a supply chain, yeah, then look into it. There is a way to look into it. And what we also need to do at the core of the assessment, there needs to be open source, that we have a framework, an open source framework, to do actually the assessment itself. And itself, it would be also great if the corporation itself would use open science practices to do their report. Because I actually asked a lot on social media and people all around, can you show me actually one company that does open science for their sustainability report? Can you imagine how much I found at the end? It was like let's say I found some very small companies, but I cannot tell you any name that you all know that is doing this. And this is really a huge problem. If one would start it would be great, because this data would be so helpful to change the other part of the industry. Yes, so let's say that's the last slide, and the open source, I would say, is really the most underestimated climate strategy, or let's say climate action. Open source is a great way so that a lot of people worldwide can first understand, predict together, and then also manage together what we consider all sustainable. I personally think that we need an operating system for that, combining a lot of tools together in a huge framework, so that companies, but also governments, can have a quick look about, okay, here's this area, has it changed? It should not be on Google Earth Engine that is very prominent there. It should be something that we all own, because it's really our operating system for the planet itself. Yes, the report, it would be great to get any feedback from you. We did a lot of recommendations there. Actually, we had so many ideas together. What could we do now in the future out of this insights that we create? We said, okay, just give them to the public. Let's all write them down. And there's much more, like, for example, and I would also like to see this much more, to actually educate poor people in the global south in environmental sustainability, and especially about, for example, satellite data processing. So you have a win-win-win situation. You educate people in software development, and you use the environmental sustainability as a perfect use case, because suddenly they can really help to look at their own places. Because if we are here sitting in our ivory tower, actually, then in saying things, they maybe do not trust us. But if there are people and can create this information, this is much more trustworthy. Yes. So we want to repeat this report to really measure the state of environmental sustainability from time to time. I hope we can do it actually every year. And I would really love to get more people involved, more insights, to create more interviews, to create more. Actually, we want to see into the dependencies. We want to see the usage of the project. And also, that's the problem, this database needs to be curated from time to time, to update the database. That's one of the hardest works, actually, to really get in all those topics and see what's the new open source projects. But there could also open source tools help us, because we have now the database to find new tools that can be done based on the data that we already collected. Yes, so it would be, if you're interested in contributing in such a thing, just go to report. At the bottom you find a section that is called How to Contribute. Write us an email, and I hope that you got a good impression about what this means and what it could mean, what is open source in environmental sustainability. Thank you so much.
A couple of down here for questions.
Yeah.
Yes, I think I present myself. Sorry. Sorry? Okay. Sorry. My name is Stefano Bonf. I'm from Oxford Sustainable Development Enterprise. And I do suspect that what you mentioned about the Oxford Health database is the Financial Institute of Oxford that do this type of work.
Yeah.
Now, but the question is this. My question is, yes, it's a very good presentation. I understand what you want to reach. And the idea that we are developing is to have a full system. This means not just data at the beginning, and then you need to have also the platform and the analyticals like Stack, and to use the data more in a concept of space data science, where then you can understand, let's say, the situation of the area, as well as you can even predict what's happened. This is we call this process here digital twinning, that we try to move also towards metaverse in a way that if you have this global, systematic, integrated approach, then you can solve your problem. One of the issues we are experimenting, we are experimenting this type of situation in, let's say, EU project in Europe. But the most difficult are people. Means how the people understand the process. And this is a key role is the educational aspect, where it should play a big role about this concept. I appreciated your approach, and I think I do agree.
Just one word there. I don't think it's possible to do in one university. We need to recombine the existing tools, because you see here the people that are already there. It's not possible in one institution, but it's a good step.
I mean, we are experimenting. This means if you demonstrate something locally at, let's say, any place, then you can replicate this understanding to other place, and that's where this scaling approach.
So there was a slide you had that had kind of different levels of popularity, or the number of projects in different categories.
Yes.
Did you notice any kind of correlation with there's more projects in this kind of area because there are more, maybe the data is more easily collected and published, or that governments have been pushing that kind of data, so there's more projects that is based on that? So where there are less popular projects, is it because that data is harder to come by, and so it's more difficult to build a project on top of it? Did you notice that kind of correlation, or is that just something that's popped up?
Eirini has.
It's just someone like a friend.
Okay.
But again, I can get that, and we can answer that. We saw that in areas where you have lots of open data, so there's like a more robust and more mature ecosystem of packages as well. There are other areas that are generally more new, like bioenergy or carbon capture and removal. They're like literally more new spaces. So that contributed to the fact that there were not enough data, or the culture of openness was not there. But I don't think we could. I couldn't see any more patterns than that. I guess it goes down to the different cultures that exist in the different communities. Like some of the oldest projects, for example, were in environmental monitoring, satellite, energy. So that comes already the ethos that started from academia, actually, propagated forward to kind of what we see today. In other areas, that is not the case because they're maybe more dominated by private sector or they're more emerging generally.
One thing on data, we also want to get the data from the software. There's a way we found to actually create now getting the data behind the models. That could be very interesting also. Then you can actually better answer your question.
Hi there. I wonder about the pie chart of the different actors. You mentioned community, non-profit, and all these actors, but I'm very interested in the collaboration. Yeah. Those ones that say collaboration, well, I don't understand well what maybe collaboration means in this context. Yeah.
It's a combination of non-profit with for-profit, where actually multiple of those forms were coming together in something larger, where we could not actually say it is a non-profit or a for-profit, but it was also not a community. Then it normally is a collaboration between a lot of different organizations that are coming together. It's not when it was just, let's say, a lot of for-profit coming together, we still consider it as a for-profit. But it's true, we should maybe improve that.
Okay, yeah, among these actors, do you think there is one of these actors that is going to elevate more, like play a pivotal role, is going to grow more in the future? I mean, communities are growing more, or academia, or you see collaboration growing more?
I hope for-profit growing more.
For-profit?
For-profit. That's the point. Because in open source in general, there's this huge movement now, let's say commercialized open source software. And I see talks about this everywhere. But in this area, nobody really tries to commercialize open source software. It's not always good to commercialize open source software. If a climate model should not be open source, then it's maybe, if you're dealing with biodiversity, it's maybe also not should be in open source. But other areas, especially if it's about solving problems, maybe doing the management of sustainability within a company. Why is there an open source framework to manage in general sustainability within a company? You can actually make good money with that, I think.
So you spoke a bit about the amount of money that is going into sustainable investments. What are like the key touch points within that movement that we can use to push money towards more open source development and research on climate? Like, what's the message that you would use to gain access to that?
Changing the wording. They all talk about transparency, but transparency in data processing is actually openness. That's what I normally do. And the other way is really also to tell people who are in decision making to ask about the traceability of this plot. Maybe people do not understand the software models, etc. behind it, but there is actually a way that you can measure transparency and traceability within your knowledge creation by just asking, okay, you have seen a plot with the chain, okay, from data, and if there's any black box within, actually your uncertainty unfortunately becomes unknown. So you need to measure the openness, and that's why I have this key indicator. You can measure openness from my point of view. You can measure, okay, is your data open? And if you have a way to measure that, you can actually say how transparency is your result at the end. And if there's the problem is actually if you have a big AI in between, it's totally untraceable. Just to give you this, because nobody understands AI.
I've got time for one last one.
Sorry, Tobias, just one last one.
Tobias,
sorry, just one last one. Excuse my naivety here. You were talking about before the licensing and the way you could then go and get data from the different sources of information, but some of it was restricted due to the licensing that they had applied. So what licenses would you suggest? Like if I was to start a new project, put it out on GitHub, what license should I assign to it so then you have full access so your data is actually more up to date and more truthful in what you present?
So the license really depends on what you want to do. if you want to preserve a community over a long time, and you want, for example, that it is a non-profit project, it really depends on what you want to do. It's not an easy question, and there's no easy answer. But I can say, if you want that your software and your data is being used within a company, then it's easier for MIT. But if you want to scale this community and you need the feedback and you need actually contribution from those companies back, the GPL can be better. But the GPL has the problem that some companies just say, oh, this GPL, that's too complicated maybe for us, go with the easy license. There is really no easy answer. It's always depending on your use case. It's, for example, the GPL is sometimes problematic if you really want to create a product out of it. Then the company cannot maybe create a product out of it because they have some other, let's say, core knowledge within those combined with this software that you can actually, they don't want to actually do also open source. So there's a reason why we have so many licenses, and it's good that we have them, but you should use one of the standard licenses.